Hi, grade 12. Welcome back to our YouTube channel. There's been quite some time without recording a video. So what I'm going to do here, I'm going to continue with differential calculus. So a few years back, I did a video on the differentiation using the first principle or using the differentiation. So here I'm going to be exploring a new or another method of differentiation that is called the power rule. So basically, throughout your grade 12, when you are asked to determine the derivative of a function, you are mostly going to use the power rule. You are only going to use the first principle if the examiner instructs you to do so. So power rule, it's the rule that I've summarized here with an if statement. So it reads as follows. If y is equals to ax to the power n, or to the exponent n, then dy over dx is the derivative of the function with respect to x. Dy over dx is equals to a times n x n to the power n minus 1. So basically what we do here in the power rule when we want to determine the derivative of the function, we take the exponent of a term, we multiply it with the coefficient, then we also reduce the exponent by 1. So that will be the derivative of that particular term. So let us look at, let me do one example here so that you get to see what is happening. So if, for example, y is equals to x cubed plus 2x to the power 2 minus 3x plus a 2, determine dy over dx. The main question here is that what is dy over dx? So we're going to apply the power rule. So this will be our example 1. We're going to apply the power rule. So dy over dx will be given by, we'll start with the first term, which is x cubed. So you'll know that the coefficient of x cubed here, it's 1. We're not allowed to write 1x or 1y. The coefficient is there, it's just invisible. So we know that the coefficient of x cubed is a 1. So here we're going to have 1 times the exponent. Remember, we take the exponent, we times it with the coefficient. That's 1 times the 3, x, and then what do you do to the exponent? So to the exponent, we reduce it by a 1. So this will be exponent 3 minus a 1. So we're done with the first term. So we'll go to the second term. So in the second term, we're going to have plus the coefficient here is 2. So we're going to take the coefficient, we multiply it with the exponent. So this is going to be 2 times a 2, x, and then we reduce the exponent by 1. So this is 2 minus a 1. Done with the second term, go to the third term. So in the third term, the coefficient there, it's minus a 3. So we're going to have minus a 3 with times the exponent. So the exponent here of the variable, it's 1. So the 1 is there, but it's invisible. So that's going to be 1 times minus 3, and then x, and then we also subtract 1 to the exponent there. So this is going to be 1 minus 1. So what you must know is that the derivative of a constant or the derivative of any number, it's always a 0. So you don't have to think twice here. So every time when you have to determine the derivative of a number with respect to x, the answer is always going to be a 0. So this is a 0. And then, but this is not the simplified version of the answer. So you must make sure that you simplify it. So you're going to have 1 times the 3. It's going to give us 3. And then x exponent 2. So that's going to give us 3x squared. And this is going to be 2 times a 2, which is a 4x, and then to the power 2 minus a 1. So this is going to be x to the power 1. Mathematically, we know that we're not allowed to write x to the power 1. So we're going to leave it as x like that. And then this one is going to be minus 3 times a 1, which is going to give us minus a 3. And then this is supposed to be x to the power 0. So anything to the power 0 is 1. So I'm just going to indicate this so that people don't get lost along the way. So this is going to be x to the power 0 plus a 0. And then you know that this must also be simplified because we cannot necessarily write x to the power 0. So this is going to be 3x squared plus 4x, and then minus 3 times x to the power 0. Remember, anything to the power 0 is a 1, so this is going to be minus 3. So dy over dx of that particular function is given by 3x squared plus 4x minus a 3. So when you're doing grade 12, you don't have to necessarily include the steps. As long as you can get the final answer, you're going to be marked correctly. You're going to get full marks. That's what I'm trying to say. So you don't have to show the steps. Here, I'm just showing the steps. I'm doing it for those that are doing the power rule for the first time. So let me also do another example. Say, for example, we are given if y is equals to 1 over x cubed plus root of x plus a 3. And they say to you, determine dy over dx. Okay, so I want you to notice something with the power rule. So with the power rule, for you to be able to apply it, you need the coefficient, the variable, and the exponent. That's how you're going to apply the power rule. So you always need the coefficient, the variable, and the exponent. So I want you to look at something here. Look at the first term, 1 over x cubed. So when we look at 1 over x cubed, 1 over x cubed is not in a standard form because something that is in the standard form, according to the power rule, it must be in the form of x to the power n. We need to see a coefficient, a variable, and the exponent. So 1 over x cubed is not in that form. So for you to be able to determine the derivative of this function, you must make sure that you write each and every term in the expression in the standard form, and then you can determine the derivative. So that's what we're going to do here. So we're going to first write 1 over x cubed in the standard form. So this, we're going to use the laws of exponents, if you remember them. So if it's 1 over x cubed, this is the same as x to the power negative 3. So now we have the exponent, the coefficient, and the variable. So that is the standard form. The same thing we're going to do with the second term, the root of x. So with the root of x, we're going to make sure that we write it in the standard form. So we know that anything that has a square root is the same as that term to the power 1 over 2, or to exponent 1 over 2. So x, root x will be written as x to the power 1 over 2. And then the 3 is fine, it's a constant. So now we've got the function in its standard form. So make sure that your function are always in standard forms. Then from there, that is when you're going to determine dy over dx, which is the derivative. So then for dy over dx is equals to, remember I said, you don't have to show the steps, but I'm going to show the steps here in this video. So this is going to be the coefficient that is here, which is 1. So this is going to be 1 times the exponent, which is minus 3, x, and then we subtract 1 from the exponent. So this is going to be negative 3 minus a 1. Then we go to the second term plus the exponent there is 1 over 2 and the coefficient is 1. So this is going to be 1 times 1 over 2, which is the exponent. And then we also subtract 1 from the exponent. 1 over 2 minus a 1. Then remember we said that the derivative of a constant is always going to give us a 0. And then this will be equals to negative 3 times a 1. That's going to be minus a 3. And then minus 3 minus 1, that is going to be x to the power minus a 4. And then 1 over 2 times a 1, that's going to be positive 1 over 2. And then x, 1 over 2 minus 1 is negative 1 over 2. So this will be dy over dx of that particular function. So I hope you see how we're going to determine the derivative using the power rule. The main thing that you must focus on is that the expression must be written in standard form. Then after ensuring that the expressions are in standard form, then you are going to use the power rule. Let me do the last example with you. Number 4, number 3, if y equals to, let's check this one. If y is equals to x squared minus a 2x plus a 1 over x minus a 1 over x minus a 1. Okay, so then dy over dx is equals to, so here we're trying to get dy over dx. Again, let us look at the expression. The expression now, we are realizing that it involves a fraction. There's a denominator x minus a 1. And as far as I remember, we never talked about fractions in the power rule. So whenever you encounter a fraction in your question, it means that your expression is not in its standard form. So before you use the power rule, you must ensure that this particular expression is written in the standard form. And how are you going to do that? Get this expression to be in its standard form, we need to eliminate the denominator x minus 1. And how are we going to eliminate this denominator? We're going to eliminate this denominator by factorizing the numerator and then we simplify. So what is it that we're going to do there? If we check the numerator, so I first simplify my y before I get dy over dx. So my numerator is a trinomial. So I'm going to factorize the numerator because it's a trinomial. So I'm going to open 2 brackets and then I'm going to have an x here, an x here. And then we look at the factors of positive 1, that when we multiply them, they must give us, we look at the factors of positive 1, that when we sum them, they're going to give us minus a 2, which is the middle term. And then that is negative 1 and negative 1. So that those are the terms that we have, or those are the factors. And then over x minus 1. And then from here, we're going to simplify. So this denominator will divide x minus 1 in the numerator, and this is going to be y equals to x minus a 1. So basically, we're determining the derivative of x minus a 1. So x minus a 1 is in its standard form. So if x minus a 1 is in its standard form, we're going to determine dy over dx. So therefore, dy over dx will be equals to, there's exponent 1 that is there. So this is going to be 1, which is the coefficient, times the exponent, x to the power 1 minus a 1. Remember, the derivative of a constant is a 0. So this is going to be a plus 0. And then this will give us 1 times a 1. And then x to the power. So this is 1 times x to the power 0. And then which is going to give us a 1. Because remember, everything to the power 0 is a 1. So that's basically 1 times a 1. So that's a method of differentiation called the power rule. So in our next videos, as we do differential calculus, I'll be applying the power rule to determine the derivatives. So in those videos, I won't be showing the steps because you don't necessarily have to show the steps. You can get to the final answer as long as you make sure that you have applied the power rule correctly. I hope you enjoyed this lesson. Like, share, and subscribe for future videos.